All right, ladies and gentlemen, in this video we are going to discuss the special properties of our rhombi. All right, and so in order to kind of start some things off with, I just want to have a little example problem just to kind of recap what we know about rhombi. Just classify the special quadrilateral and let's explain your reasoning. Well, I know for sure that this is going to be a rhombus. How do I know that? I know that because it has four congruent sides and is a quadrilateral. By definition, that makes a rhombus, right? By definition, that is what it tells us. I know it's not a square because one of the angles is 70 degrees. And I know that it's not just a plain old parallelogram or a quadrilateral because it does have those four congruent sides. So what else do we know about rhombi? Well, we know some things about the rhombi diagonals and the rhombi opposite angles. So the diagonals do two things within each other inside of a rhombus. The diagonals are perpendicular to one another. That's super important to know because think about what happens here then. If these diagonals are perpendicular, what ends up forming? Well, we end up forming four right triangles, and then things like Pythagorean theorem and trig functions that we'll get to at some point in time as well too, SOHCAHTOA, things like that could also be utilized to our advantage. And then we also know that for the rhombi, the opposite angles theorem tells us that the diagonals in fact bisect the opposite angles. So if we're trying to find, for instance, the measure of one of these angles, maybe for instance AD and whatever this point is right here, we could use this concept to realize that the diagonals will split the opposite angles in half. So let's take a look at an example of where we can use some of these characteristics. It says, what are the measures of the numbered angles in rhombus ABCD? Well, because it is a rhombus, it does have all the characteristics of a parallelogram, meaning the opposite angles are congruent. So the measure of angle 1 is equal to 100 degrees as well. But what about angle 2 and angle 3? Well, I know for sure that because it's a parallelogram, the consecutive angles are supplementary, meaning that the measure of 2 and 3 combined equal 80 degrees. Again, how did I get that? Because I know that A, the whole angle A, and angle D are supplementary because they are consecutive to one another. So 180 minus 100, together 2 and 3 have to be 80. Well, we just found out that the diagonals bisect opposite angles. And so that means that really 2 and 3 are the exact same angle. So I could just call both of these x, and I end up seeing that 2x equals 80, or of course, x equals 40. And so the measure of 2 and the measure of 3 are each 40 degrees.